All right, we'll add one question this week about the second problem on the exponential growth assignment, which was the first assignment of the week. So let's take a look here. I have to graph g of x equals -5 times 8 to the x, and here's the parent function, 8 to the x. All right, so I wrote it down here already, and one way to do these, of course, is with reference points. So I have the reference point started. Just remember the second reference point, the y value is the base, okay, or that b value of the parent. All right, so those are our reference points, and then how do they change? And yeah, this might not have been covered in the original video. You know, I can only fit so much in 20 minutes. So if you do have an a value here, you know, this is a equals -5. And if you think about it, you know, what a does, it changes the y value. It's just like when we've done transformations throughout this year. A has always changed the y values. It causes vertical stretches and compressions. Reflections over the x-axis, which that's also a change in y. So what you're going to do is basically multiply your y values by -5. Okay, is what this you know, ends up doing. So we'll still have 0 and 1 here. X does not change. We don't have an h. You know, h is just 0 here in this problem. So, and then 1 times -5, well, that's -5. 8 times -5 is -40. So those would be our reference points. Okay. So yeah, and you might be like, well, you know, looking at these graphs, where do I find those? Well, if you, one other tool that might help here is Desmos, because yeah, it's a little bit, this doesn't go up to negative, it doesn't go down to -40. It would be, I can already tell it's going to be a, and how I know that, I know the parent has to be going upward, okay, because it's positive, and g of x is going downward. Okay, but let's say maybe your problem, maybe you had two that looked like this. How could you, you know, sort of eliminate which one is which? So you might need to go over to Desmos. I'll go ahead and do that. This gave me, you know, a little bit of an idea of, you know, where the graph is heading. You know, it's going to -5. I can tell that it goes through, it looks like about through -5 there when it hits 0, and that's the only one. Maybe actually this one does also. Okay, but I know f of x doesn't go down. All right, but yeah, you could use Desmos if you further needed to you know, narrow down your options. Let's see if I can get it to fit in this small space here. Okay, so g of x equals -5 times 8 to the x. And yeah, so we can tell it goes downward. It goes through 0, -5. And yeah, so you could use the y-intercept. I don't think they would give you two options with the same y-intercept that both go down. I could be wrong about that. They might do that. So that's another thing you could use to do number 2 here. All right, so let me fill in all this stuff. I know this was giving some, this is probably where people were having the most difficulty here in getting HRW to accept your answer. I had a couple people email me like, I think I'm doing this right, and it's not, you know, taking my answer. Part of that, well, let's fill out the answer, and then I'll talk about why that was happening. All right, g of x is a vertical stretch, right? Because we had, here, let me go back to my, yeah, we had a vertical stretch of 5, or horizontal compression. Okay, I guess we haven't really covered that, but they're basically opposites. And then combined with a reflection about the x-axis, because it's negative. The domain, looking at, oh yeah, it's A, let me select that. The domain of f of x, the parent function, well, that'd be -infinity to infinity. And the range of it goes from 0 to infinity. Okay, all these parent functions, or y is greater than 0, same deal. All right, for g of x, the domain is also going to be -infinity to infinity. Range is going to go from 0 to -infinity, or in other words, y is less than 0. The y-intercept of f of x, well, that's just going to be that first reference point here, 0, 1. And then the y-intercept of g of x, that's going to be, now this doesn't always, it's not always the second reference point, okay? Yeah, this just so happens to be because x wasn't changed, but 0, -5 would be it. If you didn't, if you didn't see it here, you could use Desmos to get it. There'd be various ways. So let me check my answer. I got it right. Now here's what I noticed. Some people were getting, it was saying their answer was wrong, but the Wiener, and it was saying, my.hrw.com was saying that there was something wrong with the y-intercepts, but there wasn't. So that's a bug in the system. I apologize for that. I have no control over that, unfortunately. I saw one person's answer, they had the range wrong, but it didn't tell them they had the range wrong. It said that they had the y-intercepts wrong. So I apologize for the bad advice it's giving you sometimes on that try again. If I get it wrong, I would say try again. And then it tries to give you some useful feedback, but sometimes it's not very useful and, in fact, misleading. So just watch out for that. That's a little bug in the system. I haven't used this extensively before. I'm trying it out for distance learning, so I apologize about all the kinks here. Just be sure to email me if you run into something like that. I've gotten that a few times from people. Hey, I think I'm getting my answer right, but it says it's wrong. Feel free to email me. That's totally understandable. All right, so that is that. That's it for this week. I hope you guys are doing well, and look for the videos coming out for next week.